Hello, this is the lecture number 8 for the chapter integration of class 12, and we are discussing the exercise 7.4, which consists of a integration of a special integral, and we are discussing to how to integrate by making the perfect square, and we have done the question number 10. Let us take again the question number 11. This is also an integration by making the perfect square. See the denominator very carefully. We have, without the square root, we have a quadratic polynomial, and we have to make it a perfect square. So how we have to make it a perfect square? First of all, I've just as I've told you in the last lecture, to make it a perfect square, you have to make the coefficient of x square as 1. So you make the coefficient of x square as 1 by taking 9 common. So it will become x square. 6 upon 9 will be equal to 2 upon 3 and 5 upon 9. Then I've told you to make it a perfect square, adding and subtracting the square of the half of the coefficient of x. Now what is the coefficient of x is 2 upon 3. So the half of 2 upon 3 will be 1 upon 3. Half of 2 upon 3 is 1 upon 3. So squaring and adding 1 upon 3 whole square. This 1 upon 3 whole square, 1 upon 3 whole square. So this is become the whole square of x plus 1 upon 3 whole square minus 1 upon 3 plus 5 upon 9 minus 1 upon 9 plus 5 upon 9, it will be equal to 4 upon 9, which is equal to 2 upon 3 ka whole square. So it become a special integral of 1 upon x square minus a square. 1 upon x square plus a square, which is 1 upon a tan inverse x upon a. A special integral of 1 upon x square plus a square is 1 upon a tan inverse x upon a. And arrange it very carefully. Again, in question number 12, we have a quadratic polynomial in the square root. Now to make it a perfect square, you always make the square coefficient of x square as 1. We have the coefficient of x square as minus 1. So take minus common here. So it will become x square plus 6x plus 7, adding and subtracting the half of the square of the coefficient of x. And the half of coefficient of x will be 3, because the half of 6 is 3. So adding and subtracting 3 square minus 3 square. Adding and subtracting 3 square and 3 square. So it will become the whole square of x plus 3, a square plus b square plus 2ab. Taking care of this minus sign, so x plus 3 whole square minus 9 minus 7 16, it is 4 square, and arrange this minus, it will become 4 square positive, and this will become negative, and this become a special integral 1 upon under root a square minus x square, which is equal to sine inverse x upon a, which is equal to sine inverse x upon a. It means you have to make the coefficient of x square as 1 whenever you have to make it a perfect square. Again, we have dx upon under root x minus 1, x minus 2, multiply and open the bracket. The coefficient of x square is already 1, and you have to add and subtract the half of the coefficient of x. The coefficient of x is 3, so half of it will be 3 by 2. So adding and subtracting 3 by 2 whole square minus 3 by 2 whole square. This become a whole square of x minus 3 upon 2 minus 9 upon 4 plus 2 will become 1 upon 2 ka whole square. This is 9 upon 4 plus 2 minus, it will become 1 upon 2 whole square. So it become a special integral of 1 upon under root x square minus a square, which is equal to log x plus under root x square minus a square. In place of x, we have x minus 3 upon 2. In place of a, we have 1 upon 2. Simplify the square root, and this, it will become 2x minus 3 upon 2. It will become x square minus 3x plus. When do the whole square and simplify, you will get this as it is, like this. Again, this is question number 14. It's just as question number 12. In the square root, we have the coefficient of x square is not plus 1. So take minus common. Adding and subtracting the coefficient, half of the coefficient of 3, which is 3 by 2 whole square plus minus. So it will become the whole square of x minus 3 by 2 ka whole square. And when you simplify these two terms, that is minus 9 upon 4 and minus 8, it will become 41 upon 4, which is the whole square of root 41 upon 2. Arrange this negative sign, it will become positive, it will become negative. Square root is there, and not by mistake I have removed the square root. So square root will be there. It is under root 41 upon 2 ka whole square minus x minus 3 upon 2 ka whole square, which is a special integral of dx upon under root a square minus x square, which is sine inverse x upon a, which is sine inverse x upon a. Question number 15 is same. to make it a perfect square, it is dx upon x minus a into x minus b. Multiply and open the bracket. It will become x square minus ax plus b into x plus ab. Half of a plus b is a plus b upon 2 ka whole square. Adding and subtracting, and this become the whole square of x minus a upon a plus b upon 2 ka whole square. And when you simplify this, minus a plus b upon 2 ka whole square plus ab, you will get this a minus b upon 2 ka whole square. See it very carefully. You take your own time to this to calculate. You can use 2 to 3 steps to come from this step to this step. I've written it directly. It is a minus a plus b upon 2 ka whole square. When you simplify the last two terms, you will get a minus b upon 2 ka whole square, and it become a special integral of 1 upon under root x square minus a square, which is equal to x plus under root x square minus a square. In place of x, we have x minus a plus b upon 2. In place a, we have a minus b upon 2. Take your own time to simplify the square root and this bracket, and you will get this answer. Question number 16 is very simple. It is 4x plus 1 upon 2x square plus x minus 1. When you let 2x square plus x minus 3 is equal to t, 4x plus 1 will be cancelled out when you replace the value of dx, which is equal to dt upon 4x plus 1. So when you replace dx, this will be cancelled. So it will be only 1 upon root t, and you can integrate it. T ki power minus half, t ki power minus half plus 1 upon minus half plus 1 will get root t. You can learn the integration of 1 upon root x is equal to 2 root x, because the derivative of 2 root x is 1 upon root t, and replace the value of t. Now after that we have come to the question which will be known as linear upon quadratic time questions. Linear upon quadratic. Question number 24 you can try yourself by making the perfect square. This is linear upon quadratic. Whenever you are getting a question linear upon quadratic, what you have to do, you have to make the derivative of the quadratic in the numerator and break into 2 integration. It is linear upon quadratic type question. So x plus 2 upon x square minus 2. Now the derivative of x square minus 1 is 2x. So you must obtain 2x in the numerator. So how can you obtain 2x? Multiply and divide by 2. So 2x plus 4 it will be there, 2x plus 4. Now the derivative of x square minus 1 is 2x. So break into 2 integration in which the one term should contain the derivative of x square minus 1, which is 2x. So first integration is 2x upon under root x square minus 1, and second one will be 4 upon under root x square minus 1. See, minus half will be there. Now when you let x square minus 1 will be equal to t, and when you replace dx, this 2x will be cancelled out. It will be only dt upon root t, and this is a special integral of 1 upon under root x square minus a square, which is equal to log x plus under root x square minus a square. You know the integration of 1 upon root t. Take this t ki power half in the numerator and use the integration of t ki power minus half plus 1 upon minus half plus 1. The remaining question of this exercise is just as same. We have discussed the question number 17, which is linear upon quadratic type question, and they are very, very important to be very, very careful. Now linear upon quadratic, and you have to obtain the derivative of the denominator in the numerator, that is 6x square plus 2 you should have in the numerator. We have 5x minus 2. So how can we obtain 6x plus 2 in the numerator? Now how can you obtain 6x here? You can obtain 6x here by taking 5 common in the numerator. So it will become x minus 2 upon 5. Now how can you obtain 6? So multiply and divide by 6. So it will become 6x minus 12 upon 5. Minus 12 upon 5. Why obtaining 6? Why we are bringing a 6 here? Because the derivative of 3x square is 6x. So that is why I am bringing here 6. By making first of all the coefficient of x as 1, by taking 5 common, multiply and divide by 6, 6x minus 12x. Now what we need in the derivative of the denominator, 6x plus 2. So adding and subtracting 2 in the numerator. Adding and subtracting 2 into the numerator, because we need the derivative of the denominator. So 6x plus 2 minus 2, break into 2 integration containing the derivative of the denominator in the first, and minus 2 minus 12 upon 5. Minus 2 minus 2 upon 5, that is minus 10 minus 12. Minus 10 minus 12. So it will be minus 22 upon 5. Minus 22 upon 5 upon 3x square plus 2x plus 1. So like this you have to do these types of questions in which you have to convert in the numerator the derivative of the denominator. In the first integration we have the derivative of the denominator. In the next, we'll get a special integral. To simplify this, you'll get minus 11 upon 3. And if you let 3x square plus 2x plus 1 is equal to t, this will be cancelled out. So it will become dt upon t. And the integration of this is log t when you let 3x square plus 2x is equal to 1. This t. Log t and replace the value of t. Now come to this integration. This type of integration we have just in the beginning of this exercise. This is a special integral. You have to make it a perfect square by taking 3 common here to make a coefficient of x square as 1. Then adding and subtracting the whole square of half of the coefficient of x, which is 1 upon 3. Adding and subtracting, this become the whole square of x plus 1 upon 3. And it is 1 upon 9 plus 1 upon 3. It will become root 2 upon 3 ka whole square. So it will become a special integral of 1 upon x square plus a square, which is equal to 1 upon a tan inverse x upon a, and arrange. Again, we have 6x plus 7 upon this. Open this bracket in the denominator. You have to bring the derivative of x square minus 9x plus 20 in the numerator. So take 6 common in the numerator. Multiply and divide by 2 in the numerator. 2x plus 14 upon 3. So that is 7 upon 3. Adding and subtracting 9, because the derivative of x square minus 9x plus 20 will be 2x minus 9. So adding and subtracting minus 9. So minus 9 plus 9. So minus 9 plus 7 upon 3 will be 34 upon 3. Break into 2 integration, derivative upon this and this upon this. In the first integration, you should have the derivative of the denominator, and the other should have the only the quadratic polynomial. So you let this is equal to t. Naturally, this will be cancelled out. It will be dt upon root t. It will be dt upon root t. And you know integration 1 upon root t by taking root t in the numerator, t ki power minus half plus 1 upon minus half plus 1. And you know how to integrate this by making a perfect square. 9 upon 2 will be the half of coefficient of x, squaring and adding. It will be x minus 9 upon 2 ka whole square. Minus negative 1 upon 4 plus 20 will become 1 upon 2 ka whole square. And it is a special integral of 1 upon under root x square minus a square, which is log x plus under root x square minus a square. So like this, you can do linear upon quadratic type question. Similarly is the question number 20 and 21, 22 and 23. Now we have x plus 2 upon 4x minus x ka derivative is minus 2x plus 4. So multiply numerator denominator by minus 2. Its derivative is minus 2x plus 4. Minus 2 se multiply divide it. Adding and subtracting 4. So it plus 4 minus 8, separate into 2, first containing the derivative of the denominator, and 8 upon this and into minus half. It will be plus 4. And again, let this equal to t. This will be cancelled out. It will be a special integral by making the perfect square, taking minus common, adding and subtracting the half of x, which is 2. 2 square minus 2 square will become a special integral of a square minus x square under root mein. So we will sine inverse x upon a, and similarly you can integrate this. Similarly, this linear upon quadratic, make the derivative of the denominator, which is 2x plus 2, multiply and divide by 2, adding and subtracting 2, or you can break 4 as 2 plus 2, because we need the derivative of x square plus 2x plus 3, which is 2x plus 2, 2 plus 2. Break into 2 integration as usual. This will be the derivative of the denominator. This is equal to t. This will be cancelled out. It will be equal to dt upon tx. T, you have to write it here. T is equal to x square plus 2x plus 3. You have to write it here. And you have to make it a perfect square and it will become a special integral. You know how to make a perfect square. Like this, you have to do the this linear upon quadratic type question in this exercise 7.4, which is known as the linear upon quadratic type question, making it a perfect square and using a special integral. We will continue in the next lecture. Thank you.